So here's a fairly simple exponential equation for us to start out with. Now my advice when you're solving exponential equations is to first consider whether you can express both sides of the equation as a power of the same base. Because the exponential functions are one-to-one, if we have an equation of the form b to the m equals b to the n, then we can conclude, oops, this should be an arrow, not an equals, then we can conclude that the exponents must be equal to one another. But it's critical that you express your equation in this form before you drop the bases and set those exponents equal to each other. So it's not always going to be possible with these exponential equations. If this was 17 to the x minus 1 equals 1 over 25, we would not be able to express both sides as a power of the same base. But because it's 5 and then we have 25 here, well, we know that we can write 25 as 5 squared. So this equation is equivalent to 5 to the x minus 1 equals 1 over 5 squared. And there's a property of exponents that says if you have 1 over x to the n, that's equal to x to the negative n. So if we have 1 over 5 squared, that's equal to 5 to the negative 2. And now we've got an equation written exactly in that form. So once we know, okay, 5 to the x minus 1 equals 5 to the negative 2, then we can conclude that, all right then, x minus 1 must equal negative 2. And so if we just add 1 to both sides of this equation, we have x equals negative 1. And there's your answer. So this is nice. Let me just reiterate, it's not always going to be possible. And so when it's not possible, we're going to use logarithms as a way of solving equations like this. But I want to first show you that in some cases, and so it's good to watch out for, when you can express both powers as express both sides as a power of the same base, because then you don't have to get logarithms involved, and your answer may be pretty straightforward.